Hello, everyone. Happy Thursday and welcome. So today we are going to cover some streamlined floor flatness and levelness. My name is David Campbell. I'm an application specialist with the Topcon Solutions store. So let's get started. All right, so for today's agenda, I figured we'd kind of talk about what floor flatness and levelness is. We'll go into a little bit of the history of floor flatness and floor levelness, and we'll talk about some of the tools that are currently being used. And my goal for today for this presentation isn't really to completely change the way that you do things. I don't want to, be that huge, ridiculous person that comes out and says, "Stop! You have to do it this way." I'm here to give you another perspective on a tool that we commonly use in our industry, and we want to kind of take a look at that and see, hey, can we use this for this? Can we use it for that? One of those multi-use tools. So today we're going to talk about getting that floor flatness and levelness with a different tool, right? So a little bit about us. We are the retail division to Topcon Positioning Systems. We are a complete solutions provider as we do the office software such as Autodesk, Bluebeam, but we also provide services for hardware such as total stations, scanners, a lot of laser levels, a lot of different things. We do provide industry-leading training and technical support. As I said there, since we do support the software and the hardware, we actually support the entire workflows and support technical support for the software as well as the hardware. So we kind of do a little bit of everything. Now, being in that position, that's kind of why I'm here doing this presentation today. I've gotten to see the kind of full cycle workflow of the strength or the power that combining these hardware to software workflows that it gives us, right? The capabilities that it kind of opens us up to. So again, my name is David Campbell. I'm an application specialist for the Topcon Solutions store. I specialize in a little bit of kind of everything, a little, different things here and there: Revit, BIM 360, Bluebeam, Rithm, Verity, some scanning softwares and processing softwares here and there. So it allows me to kind of get this broad spectrum view of these different workflows and processes and have conversations with different people who are interested in learning more or wanting to train up on some of these workflows. All right, so the history of floor flatness and floor levelness. Historically, concrete floors were specified to have a deviation of less than 1/8 over 10 feet. Now, this was typically measured by laying a 10-foot straight edge on the finished floor and measuring the gaps below the straight edge. Now, I'm sure you can guess that method ultimately proved to be unreliable and prone to errors, as two people almost never got the same measurement, right? Now, it did work for a while. It got the job done, but it didn't give us the precision that we need. With today, typically they use a concrete profiling device, right? The profiling device measures concrete floor slab flatness and levelness in terms of face floor profile numbers, or F numbers. Now, somewhat like its predecessor, a concrete profiling device can also give us a straight edge over finished floor measurement. But the good thing about these devices is that typically they've been proven to be accurate to 0.01 millimeters. So that's a pretty great level of accuracy. Now, what is floor flatness and levelness? Well, the F numbers that we kind of just talked about there provide architects and contractors a method of determining the flatness and levelness of a concrete floor slab. Now, they are calculated using the standards set forth in the ASTM E1155, which is the standard test method for determining your floor flatness and levelness numbers. So I wanted to talk about this one a little bit in depth too. The American Concrete Institute indicates acceptable ranges for flatness and levelness in their guide for floor and slab, well, concrete floor and slab construction. The part that I really wanted to kind of look at here is this last portion. Architectural specifications will identify the acceptable FF and FL numbers for the project. So architects must understand the limitations of concrete slab installation. Now, this was cited from archtoolbox.com, but I wanted to really talk about that last sentence there, that the architectural specifications will identify those acceptable numbers, and architects must understand the limitations of concrete slab installation. On jobs today, let's say we have a lot of different types of, well, a lot of different types of construction, right? And we know that as technology evolves, as well, our time evolves, as everything around us kind of continues to change, we're seeing that these projects are, expecting these precise results, and our timelines are getting shorter, right? And with that, a lot of these jobs, let's say something like Amazon, right, where they have a complete, automated delivering kind of system in their warehouse. A lot of these different manufacturing companies, Amazon, they'll have to specify, right, that this slab has to be at this levelness or this flatness, so that our machines are our automation, whatever it is, even pallet jacks, right? If we're pulling a pallet jack across a floor, you want to know that that floor is level. Now, we want to look at this from a couple different ways. One, let's talk about the existing construction. To know, so looking at an architect here, right? To know what that slab is doing, or how it's deformed, what the high spots and low spots are in that building up front are going to help with the constructability and avoid any design changes later on in the process, right? And if we talk about a new construction, yes, we all have to kind of come together and realize that project's got to get, we're all going to try to reach the end goal. So a lot of times they're going to pour that slab. Now, if we think about the concrete profiling device there, a lot of times that has to be done on a finished slab, right? So one big thing here is that when we look at that, you're already past that point of where you can go back and rework the slab. Now, yes, you can call somebody back out and try to get them to adjust the high spots, or come back in and bring some concrete in for those low spots, whatever it may be. You have to get the results that you're specified within tolerance, right? Now, let me pose you all a question. We talked about how it's been done before, how it's being done today with those concrete profiling devices, and we talked about, well, a little bit about knowing what that floor flatness means and levelness means, right? And having an understanding of, well, when we get into this project, whether it's new construction, and knowing how the site moves, and knowing when we're going to pour this slab, and knowing that it's again level, or getting into an existing building, knowing those conditions gives us a lot of power, especially earlier on in the decision-making kind of process. So what about a laser scan? Now, I know some of you are going to ask, and I wanted to take a poll here really quick, but what is your experience with laser scans or point clouds? Would you say that you're a beginner? You've heard of them. Maybe you're intermediate, you've seen them, maybe use them occasionally, or would you say that you're pretty experienced, like you've used them frequently? Give a few minutes. And again, I know that quite a few of you are going to be asking, Dave, what about laser scans? What do you talk? Can we use them in this capacity? We're going to have a conversation on that right after we close up this poll. All right, so we have a little bit of experience on here, right? 75% coming up at intermediate. You've seen them or used them, and we have 25% experience. So awesome. So I mean, everybody here has a little bit of experience with a point cloud. That's great. So let's get back into that, right? What about a point cloud, right? Why should we use laser scans for floor flatness or floor levelness? Well, they give us a really good picture of those as-built conditions. Typically, one piece of equipment is needed to get the entire scan. Okay, it cuts down on cuts down on that time taking measurements and taking pictures, because typically, you know, as anybody knows that has gone out to an existing site, or even, you know, a new construction site, you will have to go and document those existing conditions and bring those in for your design. Now, again, going back into one device is needed, right? Let's think about how this data itself translates. So here, being able to look at this image, and this is part, of course, of that laser scan, and know that I'm about 17 feet, 11 and 7/8, so really close to about 18 feet from that column to the other column over there, that wall. Okay, knowing that, knowing again what my slab is doing in this instance, or where my walls are, where my openings, where my penetration points might be, and anything like that is going to give me that power to make better decisions. But also, let's think about this, the translation of this data downstream. Who else is going to be able to use this? I can use it for my concrete in this sense, and to know kind of, you know, how this slab is deviating and things like that. But also, the architect can use this information. The structural engineer can use this, and for anybody involved in this project can use a laser scan in one way or another. Okay. Now, of course, you're all probably asking, how can we use scan data and still maintain ASTM E1155 standards? Or you may be asking, does the ACI, the American Concrete Institute, support using scan data? Well, they do, and I'm going to talk a little bit more about that. So I'm going to get into a program here in a second, and it's starting out on Navisworks. So the concrete program that I'm going to be, the software that I'm going to be using today is Rithm, and Rithm is built on Navisworks. And this makes sense for a few different reasons. I really wanted to talk about Navis here for a second. Just the fact that it is, of course, our great aggregator, right? It can take in almost any type of data. Well, with laser scans, this is kind of the same case. It can take in any type of laser scan data that has been translated to the RCS or RCP file format. And when I started kind of talking about how laser scans can be, you know, used almost by anybody involved in the process, Navisworks actually is a very widely adopted software by many companies from the design throughout construction. Now, for any of you who do not know Rithm, it is a software that was designed for the concrete industry. Again, it is built inside of Navisworks. So I'm going to go ahead and get into Navis here. A nice thing about Rithm is that, yes, it does allow us to perform the FFL analysis, but kind of talking about those laser scans again, it allows us to use the structured or unstructured data, okay? Now, we talk about a few of these benefits, and I'll get into those standards again here in a second, but as I said with the concrete profiling device, at that point, when you're measuring and making sure that that slab is level, it's done, it's cured, right? In the sense of an existing slab, okay, cool, that'd be great. But if this is new construction, there's no way to know that that slab is level until we've finished it. Well, in this case with Rithm, we get in here, Rithm actually gives us the capability to analyze that concrete while it's still workable, okay? Now, ensuring that level of accuracy right from the get-go is huge. So I'm going to show you kind of a little bit about Rithm and Navisworks here. So with Navisworks, in order to get this file into Rithm, I appended the point cloud in, and then essentially I selected a section of my building here. You will need to enable your sectioning. And at that point in time, one of the best things I've found is after you draw your, get your section box right, you draw your selection, is to use fit selection. And then it'll kind of bring everything together. And then you can use your section box to raise and lower. In this case, I brought it down to almost flat. So you're going to see some of my walls are still in here. I could definitely take it down a little bit more, but I think this will work just fine for what we need. Now, to get it into Rithm, you will see a Verity and Rithm plugin here, okay? and then you can go ahead and analyze in Rithm. So after you create that section box, everything like that, you will then take it into Rithm. It's going to take a few seconds, up to a few minutes, and then it'll render in. Now, when you get into Rithm, you're going to see two different types of toolbars, a builder toolbar and an inspector toolbar. If I get into the builder, this is where you're going to find your surfaces, and a couple of really cool things I like about this. Your surface wizard helps you create, a surface that you can go ahead and export. It does send it out in DXF format, I think it is, or yeah, I think DXF. Let me double check that. Yep, there it is. So you can actually take this surface or even the contour map that it creates, and I'll show you guys how to do that here in a second. And you can actually take that into CAD and analyze those results, knowing exactly what your deviations are. Now, also, besides that, I'm going to talk about this heat map here a little bit more in a second. If we choose to do a heat map on a floor or a heat map on a floor, on a wall, a heat map on the floor or the wall, we can actually take that data and export it to an XYZ laser scan that we can take through Recap and then bring into Navisworks. So if you wanted to show that kind of heat map of maybe how a wall is bowing or how this floor is deviating right over the point cloud, you can do that. That's very powerful. Now, one thing I really like doing before I kind of analyze my floor here is I do like to utilize the debris filter. The debris filter, I'm going to bring that over here. The debris filter really helps us kind of go through and analyze this floor before, we go to do our analysis in terms of, I do have some dirt piles, I have some, cords. If this is a live construction site, you're going to have a few things laying around here and there. I mean, depending on when you scan, right? If you scan at the end of the day, you could have everything cleaned up. Now there may be cords or something like that kind of running around. This just helps you filter a lot of that information out, so you can kind of stick to where your floor is. So if I hit apply here, you'll notice it's going to go ahead and search through this. And what it's going to do is essentially light up red all around the areas that are a little outside of the tolerances that I've specified. So along with that, okay, it's still searching for these points here. I'm going to go ahead and hit cancel real quick, and this is probably going to make it spin. It's probably not going to like me, but essentially after it searches through, it'll give us the capability to add, you see add surface there. We'll be able to create a contour map or a heat map, again, after it's gone through and has, and I think I have crashed it. We'll give it a few seconds to wait for it. There we go. It responding now. Awesome. So it'll go through again, kind of filtering and cleaning up those points, and it'll really, again, clean up this scan to allow me to get the most accurate results that I can. Now, some of you, again, are wondering, Dave, that's great, but even with the scan that I have here, how do we account for, noise? How do you account for those points being kind of offset? Well, one thing I like to talk about here, and I've listened to a lot of the engineers from Rithm talk about this program. That's actually one of the reasons why they named it Rithm, for algorithm. Okay, so they have a lot of algorithms in here to offset a lot of the point data and the noise that's in there. And they have actually, they're still going through it, of course, but they've actually been able to see, I believe it was 1% off of what the dipstick, which is one of the concrete profiler tools, has been able to get pretty consistently. So they're right there. They are, again, ASTM E1155 certified, and it is approved and supported by that American Concrete Institute. Now, if I go back into my surfaces here, I'm going to show you guys real quick how to create a contour map. We'll create a heat map, and then I'll talk about the other side of this toolbar, which is the inspector toolbar. Okay, the inspector toolbar is where we're going to find things like that floor flatness report. So if I go into my contour map, what it's going to do is it's going to ask me to select the area that I want to go ahead and analyze. So I select the area. I'll start right down here around that column there. do a smaller area here. Now, I know I only have about 9 more minutes with you all, so I may not be able to run through everything, so I apologize. But if you are curious about any of these other features or how the scan data can be used to determine the floor flatness, floor levelness, I'll have my contact information up here in a little bit. Please feel free to contact us and ask any questions that you may have. So what's nice about these contour maps is the fact that we can do, well, you can specify how you want these contours to not only space, but look, right? So the spacing along the contours, we can kind of set it to where it's more crowded, or if we want some more space between them. What kind of coloring mode do you want to use? Do you want to use a high, low, a cut, fill, or plain, just no colors at all? Do you want it to run more precise, essentially like analyzing the point cloud? It may take a little bit longer, right? So it's slower. Or do you want it to go a little less precise, but it's going to go faster? Okay. I do like the slower, more precise, just because I like to get my results as accurate as I can. So essentially we'll hit OK there, and then it'll run through and give us that contour map. Now I did go ahead and make a contour map already, and I've hidden it with my layers here. So I'm going to go ahead and turn that on. Now, obviously, this first one, I definitely should have used that spacing a little bit better, right? That's where you're going to see those adjustments that you can do kind of, they make sense and they help, especially with something like this where we can see this floors. Now, this is in point, oh, let me get back into that, I apologize, there we go. This is in 0.34 feet, 0.36 feet. You can make an adjustment to how that reads. Essentially, you know, if you want to see inches, if you want to see feet, anything like that. Now, an interesting thing I did want to talk about really quick before we get into that inspector toolbar was that export process. And here we can send out that DXF, right? We can send out a CSV. We can send out those steel monitoring points if you're going to go ahead and do a beam camber analysis, anything like that. Or we can also send out that XYZ heat map that's going to go into recap, and again, you can convert over to that RCS or RCP to bring in, okay? Now, the other portion of this, I know I wanted to talk about that inspector toolbar, so I'll get right into that here in a second, but I mentioned the beam camber. Man, this is a great tool as well. If you want to try to measure for any deflection, you can use the beam camber analysis, and it'll draw a straight line from the beginning to the end of the beam, and then kind of go through and analyze if there are any deviations and how far that does deviate. Okay, that's a great tool. If I get into my reports, I'm going to find, oh, let me move this down here. This is where your floor flatness, any of those contour maps, the beam, if we did a beam report, things like that, that's where these reports will be located. Now I'm going to go ahead and get out of this one and get into that inspector toolbar. So my floor flatness report is popping up here. I ran one just before this, just in case it didn't want to, you know, cooperate with the demo. We all know how awesome live demos can be sometimes. But essentially, to do this, you would run a floor flatness, the ASTM 1155 here. And then what we would need to do is just click one point and then our second point, and then you'll draw a cross. So what we want to do is kind of make a cross or an X with it, okay? And at that point, it's going to run through and analyze our floor. You can kind of see it's giving me a profile there in the back. I hit escape one too many times there. But you can kind of see it's giving me a little profile of that floor there in the back. But if I want to take a look at these numbers, I can get into my reports. So there's that floor flatness, and it's not giving those to me. Now you can import existing floor flatness lines in, things like that. So if I did save those floor flatness lines, they would go ahead and appear. Now mine are pulling up pretty nice here, but essentially you can also send these out as floor flatness lines or in that DXF file format, okay? Now we do have about 6 minutes, so maybe let me run through this a little bit. I'm gonna go ahead and clean this off. Start fresh here. All right, and to get our floor flatness, again, we'd go ahead and click on that floor flatness. I'm gonna draw one to the left or towards the right here, draw one straight down, and I'm gonna click once and then again. And then for my second line, I'm gonna draw one here, and I'm gonna draw one across. All right, now when I'm finished, I'll simply hit enter, and it's gonna go ahead and start calculating for me after I hit that I'm ready to run that floor flatness, floor levelness analysis. So it's going to take just a few seconds here to calculate. But you know, while we have the time, do we have any questions at this point? I know this is we don't have too many people in, but do we have any questions here before we wrap this all up? All right, looking good. All right, so yeah, this is taking a few seconds. But again, it's going to go ahead and shoot up that report dialog box as soon as it's finished calculating. And what we're going to see is the 1, 2, 3 here. This is kind of telling me what point numbers these are at. Okay, and it's kind of calculating those, and it'll give me the measurement of that floor at that point. So giving me those F numbers that we were kind of talking about earlier. And what it's doing again is kind of analyzing like, okay, what is the straight floor? What is our floor at? And then again, kind of giving, just like earlier when we were talking about that straight edge, we can get a really good idea of the deviation or that spacing between the two. Okay, where it's supposed to be straight and where it's actually at. All right. So we have 2 more minutes here. We'll see if it'll kick me out of report before the time limit's up, but thank you again for joining me, everyone. I'm gonna go back into my slideshow here in a minute when I can, after I get this report to come up. Let's see here. Yep. There it goes. All right. It'll kick back on there, but you'll see essentially run 1, the floor flatness is 38.29, floor levelness is 32.86. And again, when we go through, we can see each step, and here are elevation in inches. Okay, so each one of these, it's taking that measurement right below each one of those steps, okay, and giving that back to us here. And this is where it's going ahead and giving us that overall flatness, the minimum flatness, overall levelness, and the minimum levelness. So we can go ahead and create this report and then take it out and send it to whoever may need it, okay? All right, so let me get back into my PowerPoint here. Thank you again for joining us. I hope you all learned something, and I hope that, oh, printed it. There we go, right in a blue beam for me. All right. So that's the overall kind of what it's going to look like here. It'll give us those you know, measurements and then let us know if it has passed or failed based off of our tolerances. So again, from myself and everyone at the Topcon Solutions store, thank you for joining us. And if you have any questions, please feel free to reach out.